It is user-friendly. Kids get this. It's the graphic nature of it. They can see what's happening. It's clear what's going on. Addition is about moving forward. Subtraction is about moving backwards. I see what's happening. You know, children who have been intimidated by symbol-only representations get this. And there's a whole lot of research here. It does result in fewer errors. It does require less working memory. Is this not the problem our children have who are struggling in math? I'm going to tell you something. They're not dumb. They have very little working memory. That's what their problem is. And here's a very big thing. If this is taught first, before the traditional algorithm, they have such a high level of proficiency and flexibility. What happens if you teach this after the traditional algorithm? Tell me. They don't want to do it. They don't want to do it. Anytime you teach a traditional algorithm first, you can hang up teaching mental math strategies. So everybody who knows is saying, put off teaching traditional algorithms as long as you can. Do not eliminate them. And by the way, in high-performing countries like the Netherlands, they start teaching the traditional algorithm for addition, subtraction, multiplication, and division at the same time in the same year, 4th grade. 4th grade, when do we teach it? 2nd grade. When do our kids learn it? Never. Okay. All right.
Speaking to that,
yeah.
My daughter's 2nd grader. Last year she was in 1st grade. She came to my classroom one day after school and she was so excited, and she showed me, now they didn't use like a 7 plus 5, which would have to carry. She would have done something like 32 and 45, and yeah, she drew a line down the middle, yeah, and she added the 2 and the 5 and the 3 and the 4, and she was just as excited and pleased as punch could be. So of course I was having to, tread on thin ice not to crush her little soul. And I said, or, that's 30 and 2. Do you know that? Do you understand that 32 is 30 and 2? Okay, well that's 30 and 2, and that's 40 and 5. So that could be 70, and the 2 and 5 is 7. That could be 77. And she goes, okay. And then she went right back to my board and started drawing the lines. And she just...
We see it all the time.
Yeah.
And the problem is that we have so many students who do not understand that 30 in 37 resides 30 plus 7. That is the absolute number one first place value lesson. 63% of 5th graders don't know that. If you look at the place value assessments by Thornton and Ross and by Camille, you're going to see those numbers don't change very much. It's amazing. They don't know the number one. You think the most important thing about place value is to know that there's a 7 in the tens place? Not nearly as important, particularly for mental math skills, is knowing what is called the additive principle of place value. That 342 is made up of 340 and 2. We don't teach that. We we do it. We call it that, I call it the English teacher's term. We call that expanded notation. And we do that every once in a while at the bottom of the page a little bit. That is the big idea of place value. And children who don't know that can circle on the 3rd grade ISAT till the cows come home the number in the tens place and the number in the hundreds place. And I promise you, if you go to your class, whatever grade level you're teaching, if it's above 1st or 2nd, and say, how many tens in 371, what will they say? 7. They have no understanding of place value. In fact, do you know what other countries call place value? The American disease. The American disease, because we teach it so poorly. Now, this will help children understand conceptual place value, and I'm going to show you how. Okay, now, collection, Collection-based strategies would be a traditional algorithm, okay? Or anything where you kind of work in groups instead of working as moving forward or backward on a number line, okay? All right, now we're going to talk about some big ideas. The sequential structure of numbers. You heard the word yesterday, if you were counting the word structure, at the pre-conference. Some of you weren't here at the pre-conference when they were talking about Common Core, which is everybody's, big thing now. There's the Common Core, structure. That is not a word, and I'm here to tell you math professors, that is not a word that we classroom teachers understand. The structure of number. What the heck are they talking about the structure of number? Well, we're going to have to find out what the structure of number is. And the very first structure is, it's sequential. And it grows by 1 or 10 or 100. Children need to know that. Empty number line, one of the best ways to teach it. That numbers can be composed and decomposed, and subunits or smaller amounts can be added or subtracted in various orders, yet still be equivalent. That's about structure. Structure is not about counting. Whenever you start talking about the structure of number, you are not counting. Okay, you're doing something else. You're understanding. You know what I could do? I could take this number apart. I could do 9 plus 7. Well, my gosh, that's the same as 10 plus 6. Or I could do 8 plus 4. And then I could just decompose that 4 and put that 2 over there, and then I got a 10. 10 is a structure of number. Privileging and anchoring 5 and 10. Empty number line. Teaches privileging 10. And by the way, the Pacific Rim countries that do so well in tests, guess what they teach their children to do? Privilege 10. Not doubles. They do not teach. I was at a session one time where they were talking about 10 frames, which I also talk about a lot. And we were asking the lady why they were in the doubles format, which is the incorrect format, actually, for 10 frames. And she said, well, because Harcourt hired me to teach doubles to the kids, and this is what I came up with. And a Japanese educator who is very, very famous, I won't name her, but she's very, very famous, hopped out of her chair and said, you Americans and you doubles, that's why you're so dumb. She said, we Chinese, we Japanese, we teach one strategy. Think 10, that's why we're so smart. And she sat down, and you know what? She's right. We don't privilege 10. And the empty number line is a way to help children understand that by privileging 10, you are understanding and using the structure of number.